Hi, this is our senior design project, and we designed the Wood Aggregation Center. I'm Natalie.
I'm Diego.
I'm Sydney.
I'm Ari.
And I'm Ella.
Wood Aggregation Center is a circular model where salvaged wood can be processed for optimal use and returned to local markets in Nashville. Materials from construction, demolition, and tree removal are separated based on quality, allowing reusable lumber to be recovered while lower grade materials still processed into mulch, biomass, or other products. By diverting waste wood from landfills, the facility supports sustainable material management.
When developing our plan for this project, we established three key goals. First, we sought to consider and address a genuine need. Nashville's lack of a wood aggregation center has created challenges for sustainable waste management practices. So, our goal was to develop a detailed preliminary design that Nashville city leaders could use as a foundation for future wood aggregation center development. Second, we wanted to prioritize community outreach. Our proposed wood aggregation center is not solely an industrial site. We see it being a space where members of the community can gather, learn about recycling and reuse, and contribute to hands-on wood projects. Our third key goal was to apply our structural design and site design knowledge to a real-world problem. Through working on this project, we strengthened our understanding of a variety of topics and gained proficiency in a range of practical skills.
Our project included three main steps. The first was to plan the building layout, which involved determining where our columns would go, where we would have big open spaces, and how we would arrange our building. The second step was to design all the structural components of our lightweight steel warehouse with our attached office space. Once we had designed all of the elements, we could move on to the third step, which was to create a Revit model with all the design elements and draft our design document so that this building could eventually be built.
First is the schematic design phase. So once we understood what this facility needed to do, we needed to figure out what would it look like. We wanted to have a space for the office for the workers, a workspace for the community to come and learn, and of course, a very large warehouse where trucks can drop off wood to get processed. First is the warehouse. The biggest design driver was function. This is a working facility. Forklifts, log trucks, and heavy equipment are moving through here constantly. So we need a wide open floor plan with no columns getting in the way, and a large overhead door so trucks can drive through without having to turn around. Next is the community center. At the same time, this facility isn't just industrial. It has a community center component, so we split the buildings up into two sides, a workspace side for the heavy operations and a community-facing side where the public can engage with the mission of our center. Lastly is the office. This section gets a lower ceiling and wood elements throughout, because if you're building a wood aggregation building, the building itself should represent the material that it makes. We also made it separate from the noise of the warehouse so the workers could concentrate.
In the schematic phase, we moved to the design phase, and this is where we started to design all of the elements in the building. The first step of the design phase was to figure out what loads would be applied on the building. In terms of vertical loads, the dead load and live load controlled because the snow load in Tennessee is pretty small, so those were the loads that we used for our vertical design. In terms of the horizontal loads applied to our building, we had to consider both wind and seismic, which is essentially an earthquake load. After looking at the code and applying it specifically to Nashville, Tennessee, we found that the wind load was larger, and so this is what we used when designing elements of our building. We used two different methods to support our horizontal loads. The first was X bracing, and as you can kind of see in this image, it involves creating an X that allows that creates resistance towards any forces that might shift the building side to side. And then we also created custom moment frames, and these are essentially huge trusses that span the width of the building. And these are another method to prevent the building from collapsing side to side or deflecting too much. Aside from the lateral load resisting elements, we also incorporated a bunch of other elements into our design. You can see some of them here. We designed the roof deck and the joists that would be attached. We also designed columns and beams. And then we also designed foundations and wind girts, which are elements that resist the wind in the wall so that the wall doesn't bend too much.
Next is the design document phase. We're going from our schematic 2D layout to our 3D modeling using Revit. Here's the Revit design process. Since Ella has already touched on all the different elements, here's just how they look like in Revit. Sometimes they're 2D when we're sketching the different layouts, and sometimes they're 3D when we go into 3D mode. Here's some other ones, such as the base plates. Here's a slab on grade. And here are all of our decking materials. Lastly, we had to make detail sheets. These close-up drawings show exactly how the individual connections are made. The 3D model tells you what the building looks like, but the detail sheets tell the contractor how to build it. And here's our finished model. The large windows let people inside the community center look directly out on the aggregation site, so you're always connected to what's happening outside. The wood accents on the exterior reinforce the same idea.
Thanks for watching!